Welcome to our discussion on working with fractions. You see that we're going to look at improper fractions, mixed numbers, and how to kind of convert back and forth, equivalent fractions, how to rewrite one in lowest terms, and then how to work with these things in word problems. A little quick vocabulary. The numerator is the number on top. The denominator is the number on the bottom. Don't know how you're going to memorize that. It's really not that important, except for, when you're reading a textbook and it tells you to do something with the numerator and something with the denominator. A proper fraction is just a fraction less than 1. So what that means is the number on the top just has to be smaller than the number on the bottom, i.e. the numerator has to be smaller than the denominator, right? An improper fraction is just the exact opposite. It's a fraction that is greater than or equal to 1. So, technically improper fractions are really the ones that are just greater than 1. If they're equal to 1, they just become 1 and they're no longer a fraction, right? We would reduce 8 over 8 to just 1. But, technically if you left it as 8 over 8, it's considered to be an improper fraction. But we never deal with them that way. So an improper fraction is something bigger than 1, usually is what we think about. It just means that the number on top, numerator, is bigger than the number on the bottom, denominator. And what happens is when you have an improper fraction, you will rewrite it as a mixed number, where you'll have a whole, a certain number of whole things, and then a fractional piece. So for instance, 7/3, we can write out kind of with boxes, right, to represent what they are. If 3 of these boxes is equal to 1, then we know 1 box is 1/3. And so if we have 7/3, we have 7 of those little boxes or squares. Well, each of them is a third, right? So we can put them in groups of 3, and this equals 1, this equals 1, and we have 1 left over. So there it is. 7/3 is 2 1/3. I'm sure you guys already knew that. It's nice and easy with 7/3. And there are other ways to deal with bigger numbers, right, that maybe aren't as easy to recognize. And I'll show you that here in a second. Now, it is true that 7/3 can be thought of as 2 plus a third, or just written as 2 and a third, right? That's normally how we write it, or speak it, 2 and 1/3. But we don't normally put the plus in there. We would just normally write it as the 2 and a third without the addition symbol, without the plus. Okay, how do we, convert these things more efficiently than drawing those silly little boxes? Well, it's really simple. It's the idea that we have to remember that a fraction is really division in disguise, and so that all you're doing is some simple division, right? 13 divided by 5. Well, 5 can go into 13 2 times, which is 10, and it has a remainder of 3. So there's my 2 wholes, there's my remainder of 3 over 5. It's just that simple. Now, if it's bigger numbers and you don't know how to do division in your head, you can always set it up as long division, right? 5 into 13 goes 2 times. 2 times 5 is 10. Here's my remainder of 3. And so there's my number of whole things, right? The number on top is how many whole things I have. And then the remainder goes back on top of the same denominator, because that's how many leftover fifths we had. And then we can go in the other direction. If we have an improper fraction and we want to write it, if we have a mixed number and we want to write it as an improper fraction, which we actually need to do to perform arithmetic on these things, right? If you've got a mixed number and you need to add it to another mixed number, it's far easier to do that as 2 improper fractions. And the same goes definitely for multiplication and division. It's much easier to multiply and divide improper fractions than it is to multiply and divide mixed numbers. Addition and subtraction, you can kind of get away with working with mixed numbers, but it's still a little confusing, and it's much less likely to make mistakes if you always convert mixed numbers into improper fractions before you do any kind of mathematical operations with them. It's going to make your life a lot easier. So we need to understand how to do this switch. And it's really simple. You take the whole number, the 2, right, in this case, and you multiply it by the 3, which gives you 6, right? Sorry, doing this wrong. You take the denominator, which is 5, multiply it by the whole number, which gets you 10, and then you add the top, which gets you 13. So again, you start with the bottom, because those are the number of things, and then you have to take those number of things and multiply by how many whole pieces you have, because each one of those is going to have 5 things in it, right? So 5 times 2 gives you 10, so now you have those 10 pieces. Then you add the 3 remaining pieces, and that's how you get 13 total pieces. And how big were those pieces? They were fifths, right? So denominator times the whole number added, or sorry, that's product added to the 3, and that gets you 13. Visually, this is what we're doing, right? You're taking that whole number, you're breaking it up into each whole number piece, right? So there's 2 of them, and this one has 5 fifths, 5 pieces, of a size of a fifth, and then that 3 fifths gives us the other remaining 3 pieces. You add them all together, and you can see you have 13 pieces. And how big were those pieces? They were 1/5, right? I just always remembered it as a circle, right? Bottom times the whole plus the top. Nice, simple process to get back to a mixed number. Okay, equivalent fractions, basically a fancy way of saying that we can always reduce fractions, because 2/4 is the same thing as 1/2, right? 3/6 is the same thing as 1/2, 4/8, 5/10, and we can go on and on and on as long as we want. And if you've ever looked at a ruler or any kind of measuring device, you'll always notice that there are all these little intermediate tick marks between something. And if we have something that's considered 1/2, we could also add up how many of these tick marks they are and get an equivalent of 1/2, right? So here's the 1/2, the taller one. The next size down, you can see, is 1, 2, 3, 4, 5, 6, 7. There's 8 of those spaces, so that's an eighth. And 1, 2, 3, we've got 4 of them. 4/8 is the same thing as a half, right? Well, obviously this is halfway in between the 8, so that's a 16th. And if you add them all up, 1, 2, 3, you get 8/16. So, we're already familiar with seeing fractional numbers represented multiple ways. Now we just have to kind of work backwards. When we're given 46/92 as a fraction, we have to be able to efficiently reduce it down to a half. And, you can do these things by hand by pulling out factors. Go, oh, well, they're both even, so I'm going to divide the top by 2 and the bottom by 2. And then the result will still be even. Okay, top by 2, bottom by 2. And you keep doing that, and then you get down to 5/10 maybe, and you go, oh, well, they're both divisible by 5. And then you get 1/2 and you're done. Or you can use your calculator, right? Many calculators, you can literally plug in 46/92 and hit equals, and there's like a little button, and it'll reduce it for you, and it'll spit out 1/2. If you don't have the fancy calculator that does that for you, you can also just take 46 and divide it by 92 and see what the decimal equivalent is. And if you're lucky, you get a decimal equivalent of 0.5, that's a half, or 0.25, that's a quarter, 0.125, that's an eighth, right? Things like that. When you get 0.33333 repeating, that's a third. 0.66666 repeating, is 2/3, right? So there's ways that you can kind of play with it that way. Just depends on what kind of tool you have and becoming familiar with how to work with that specific tool. Okay, so we can rewrite the fraction 2/3 as an equivalent fraction with a denominator of 18 simply by multiplying the bottom of the fraction by whatever number we have to do to get it to 18, in this case 6. But you can't just multiply the bottom by 6, you always got to multiply the top by 6 to keep the size of the fraction the same. We're not changing its value, we're just changing its label, so to speak. Right? So that's how you get 12/18. Why would you ever do this? Well, of course, you would do this when you have to add or subtract fractions and you need common denominators. How about writing something in lowest terms? Well, it's the same thing, but in the opposite direction, right? Figure out what you can divide out of both fractions. But as I said, a lot of technology will do this for you, and there are other easier ways than to trying to figure out, oh, they're both divisible by 16, or they're, I mean, obviously this is pretty obvious that you go, oh, they're both divisible by 16. But when they get more complex, like maybe 30 and 48, well, then you can write each number out as its factor pairs like this, or more precisely, what normally happens is you would take each number and you would do what's called a prime factorization of it. You would do a factor tree, and you would get it listed down as all of its prime numbers. And then once you do that, you can eliminate what they have in common, and whatever's left over is going to be your reduced fraction. So for instance, with these numbers, right, so here's 30, a factor tree could look something like this: 2 times 15, and this becomes 3 times 5. So we know 30 is 2 times 3 times 5. That's called its prime factorization, because we figured out all the prime numbers that multiply to get us to 30. And every number, you can do this with every single number. Every number is a product of primes. So 48, maybe you go, okay, well, that's 4 and 12. Oh, but then 4 is 2 and 2. And then 12 is 2 and 6. And then 6 is 2 and 3. So 48, right, becomes 2 times 2 times 2, right? There's 1, 2, 3, and then a fourth one times 2 times 3. Okay, what do they have in common? Well, there's 1, 2 here, 1, 3 here. We can get rid of both of those, right? Those will both cancel out. And what's left over? We have a 5 on top, and we have a 2 times 2 times 2, which is 8, right? You see how these two things. And the answer is going to be 5/8. So that's one way of tackling it if these are more complex numbers and you can't just look at them and figure out. But again, technology will do this for you. All right, so here's another example. Even if it's improper, we would still do it the same way. We would either use technology, or we can use the prime factorization to get what we need to get. Sometimes it's difficult to find the largest number that divides into each of these, and that's really what I've been talking about as far as doing the prime factorization trick, or again, falling back on the technology. I don't know why they think this one's a little tricky, other than the fact that once you reduce it, you get division by 1, and we just have to remember that division by 1 means nothing. And so 2 over 1 is 2, 3 over 1 is 3, and 4 over 1 is 4, so on and so forth. How about some word problems that use this kind of stuff? The pitch or the steepness of a roof is defined as rise over run. And rise is just the vertical distance from point A to point B, and then run is the horizontal distance from that same point A out to another point C. So if you think of this triangle, this is A, up here is B, and over here is C. So the rise is just how tall it gets from the center point, and then the run is how far out it gets from the center point. And we get a rise of 8 feet, a run of 24 feet, so we put rise over run, height over width, so to speak. You do 8 over 24, they're both divisible by 2, which gives you 4/12. And then, of course, you go, those are both divisible by 4, and the answer is going to be 1/3, which I guess we didn't finish on the next slide. And that would be your pitch, 1/3. Now, oftentimes, we would leave it in 4/12 in this type of application because we want to know what the rise is per foot, right? So if we had measured this in inches, we would have left it as something over 12 because that would have been 1 foot. Now, in the case of this being feet, there's no reason to leave it as 4/12. So we would make it 1/3. So we know that it rises 1 feet for every 3 feet. Okay. Which fraction is larger? Well, this is going to introduce us to a bow tie method, which we're going to see in later videos where we have to add and subtract fractions. And it's really simple for both adding, subtracting, multiplying, and dividing. Most books are going to tell you that if you want to add, subtract, or compare fractions, you always have to come up with the least common denominator. That's true, but that's not the only way. You can also just come up with any common denominator, and that's where the bow tie method comes into account. So you take this bottom number, multiply it by the top, you get 16. You take this one, bottom times top, you get 15. And then if we were going to add or subtract, you multiply the bottoms to get that common denominator. 8 times 3 is 24. And what's happened is we've now just changed this into 16 over 24 and 15 over 24. Because in essence, what we've done is we've multiplied this fraction, top and bottom, by 8, and this fraction, top and bottom, by 3. Remember, we can multiply a fraction by any version of 1, and we haven't changed its size, right? 3 over 3 is 1, 8 over 8 is 1. But by doing this, we've put them both over the denominator of 24, and now we can see very clearly that 16 is bigger, so 2/3 is bigger. The nice thing about the bow tie is we would have known that immediately once we did 8 times 2, which gave us 16, and 3 times 5, which gave us 15. We didn't even have to do the bottom part. We know that 16 is the bigger of the two. All right, so that's just a little preview of the bow tie technique that we'll see in other videos. 5/8 inch drill bit is too small for a job. 3/4 inch bit is too large. What size drill bit should be tried next? Well, in order to do that, we need to kind of figure out what's in between them. So we really need to figure out what they are with a common denominator, right? So, of course, 8 and 4 makes it pretty easy that we could just change this one to 6/8. So we get 5/8 and 6/8. So now we need something halfway in between those. All right. So then let's convert them both to 16ths. So we get 10/16 and 12/16, and then halfway in between is 11/16. That's our last example. That's all I got for you for working with fractions.